So, you hit submit on a web form, right? What exactly happens next? Well, welcome to this explainer. Today, we're totally pulling back the curtain on the foundational, behind-the-scenes mechanics that power the dynamic web applications you and I use every single day. We are going to look at the invisible Java machinery that takes your clicks and keystrokes and actually turns them into a seamless online experience. Okay, let's just dive right into this.
Here is our quick roadmap for the explainer. We're going to cover 1. The power of Java servlets. 2. Inside the Tomcat server. 3. The servlet lifecycle. 4. Evolving to Java server pages. And finally, 5. Mastering session management. Let's get going.
All right, section 1, the power of Java servlets, moving beyond static pages. To really appreciate this tech, we've kind of got to remember the early internet. Back then, web pages were just entirely static. Everyone who visited a site saw the exact same text, the exact same images, but as the web exploded, we desperately needed pages that could adapt, calculate things, and respond to individual users in real time. Think about a basic web calculator. You enter 2 numbers, click add, and the resulting page completely changes based on your specific input. Well, to make that magic happen in the Java ecosystem, developers rely on the unsung heroes of the web, servlets. Servlets are essentially just Java programs running inside a Java virtual machine, or JVM, on a web server. They're the absolutely crucial middle layer between your web browser and the databases sitting on the server. Let's actually trace this journey out. So step 1, a request leaves the client, that's your web browser, and zips across the internet to the server. Now, instead of just handing back some boring pre-written file, the server leans on the servlet to process the request. The servlet might talk to a database, crunch some numbers, and then in step 2, it dynamically generates a totally customized response right there at runtime. Finally, in step 3, that custom response gets shipped right back to you. So why do developers absolutely love servlets? Well, first off, they're incredibly portable. Since they're written in Java, you can code a servlet on a Windows machine today and flawlessly run it on a Linux server tomorrow. It's a real game changer. They're also incredibly robust. Because they're run on Java-enabled servers, developers don't have to sweat over memory leaks. The JVM just automatically handles all the garbage collection. Plus, they aren't even limited to web browsing. They're protocol independent, so they happily support FTP, SMTP, and HTTP alike. Moving on to section 2, inside the Tomcat server, the engine room. A servlet can't just run on its own, right? It needs a home, a specific environment to operate in. Enter Apache Tomcat. Tomcat is an open-source Java servlet container. Honestly, the best way to think about Tomcat is like a highly organized, bustling restaurant. And to understand how it processes your orders, requests, we need to meet its 3 main staff members: Coyote, Catalina, and Jasper. First up, we have Coyote. Coyote is basically the friendly greeter standing at the front door of our restaurant. It's the connector component that specifically supports the HTTP protocol. Coyote just listens intently on a specific TCP port, waiting for any incoming connections from a web browser. But here's the thing. Once it gets a request, it doesn't actually process the data itself. Nope, it just forwards that request deeper into the Tomcat engine. Next, that request is handed off to Catalina. Now, Catalina is the strict, highly efficient manager of this whole operation. It's Tomcat's core servlet container. Catalina implements the exact rigid specifications required for servlets. It's also the bouncer. It's in charge of security, managing what are called realms, which are essentially databases of usernames, passwords, and user roles. Catalina is the component that actually oversees the servlets. And finally, back in the kitchen, we've got Jasper. Jasper is Tomcat's JSP engine, the specialized head chef. When a request comes in that requires a Java server page, Jasper steps up, parses the file, compiles it into Java code, and whips it into a servlet at runtime. It's honestly so attentive that it can even detect when a file changes in the background and just seamlessly recompile it without ever dropping a server request. All right, section 3, the servlet and JSP lifecycle, the circle of life. Now that we know who's running the show, let's look at the actual lifespan of a servlet once Catalina takes control. It's exactly 5 steps. First, the container loads the servlet. Second, it creates an instance or object of that servlet. Third, it invokes the init method, and this is key. Init is only called once for one-time setup stuff, like opening a database connection. Fourth, it invokes the service method. This is where the real heavy lifting happens. Service runs repeatedly, handling every incoming request and deciding how to respond. Finally, step 5, when the servlet is no longer needed,
The destroy method is invoked just once to clean everything up before garbage collection kicks in.
But here is where the architecture gets genuinely brilliant. How does it handle massive traffic? Well, instead of wastefully spinning up a brand new servlet for every single user, the servlet container uses that one single instance we just talked about. Then it simply spawns a new lightweight thread, thread A, thread B, thread C, for each individual request. Each of those threads executes that tireless service method simultaneously. It's what makes the whole system so incredibly fast and scalable.
Section 4. Evolving to Java Server Pages, or JSP.
So, in the early days, trying to write complex, beautiful HTML code directly inside Java Servlet print statements was basically a developer's worst nightmare. It's tedious, it's visually messy, and it's practically impossible to maintain. To fix this, developers flipped the script and introduced Java Server Pages, or JSP. Servlets are pure Java programs awkwardly forcing out HTML. JSP, though, it acts like a standard HTML file where you can cleanly embed Java functionality using these special little scriptlet tags. This completely separates the visual design of a web page from the hardcore backend logic.
But, and this is a massive plot twist, a JSP file is actually just a servlet wearing a disguise. Yup, when your browser asks for a JSP, that head chef we met earlier, Jasper, jumps in. Jasper takes the JSP file, translates it into a Java servlet source file, compiles it, and then loads it into the container as a full-fledged servlet. So the developer gets the total ease of writing standard HTML, but the server still gets the raw, blazing speed of a compiled Java servlet. Best of both worlds. And that brings us to Section 5, Mastering Session Management, the memory problem.
We've got dynamic pages now, sure, but there's a huge hurdle left. The internet runs on HTTP, and HTTP is an entirely stateless protocol. In plain English, it has total amnesia. Every single time you click a link, the server treats you like a total stranger it's never met before. So think about that for a second. If the server instantly forgets you after every single click, how on earth does your shopping cart stay full as you browse? How do you stay logged into your bank?
To cure this amnesia, developers use session management. Imagine you type your name into a form and hit go. The server needs to grab that state, that data, pass it to Servlet 1, and then cleanly pass it again to Servlet 2. We essentially have to keep your tab open across multiple, entirely separate clicks and interactions. So how do we pull this off? Well, there are a couple of main techniques. First, cookies. The servlet creates a tiny little text object with your info and sticks it directly into the response sent to your browser. Then your browser politely hands that cookie back on the very next click. Another super common, highly secure method is using the HTTP session interface. By calling request.getSession, Tomcat creates a dedicated, persistent session between the client and server. It's basically like an invisible VIP wristband that carries your state with you across the entire web application.
Honestly, it's a highly orchestrated dance of technology, and it's all happening in the blink of an eye. So here's my challenge to you. The next time you log into a portal or toss something in a shopping cart, take a second to look through the screen. Think about Coyote greeting your request at the door, Catalina spinning up a dedicated thread just for you, and Jasper frantically compiling HTML in the back. What invisible Java machinery is tracking your session right now? Thanks for joining me for this explainer, and hey, stay curious.